Excellent. Any other questions / comments? Thank you. All right. Yeah, question. What's that? Oh, I haven't started the attendance yet. Just going to get to that. I have to say, I'm taking attendance now. Now you should be able to click and have it work. So yeah, please tell me that you're here. And if we're all doing okay, let's get started. Let's go to scratch.mit.edu. Today's a programming day. Oh yeah. So today I want to talk more about loops. I gave you like a teaser last time, just a very simple repeat block. We're going to go further than that and do much cooler stuff today. Okay, so it's about loops. That is the main topic. Okie dokie. So what is a loop, right? Normally, when we write code, it's a bunch of blocks that execute after each other, right? This is what we had before we got into the if blocks. So a bunch of these blocks, they execute in order. So like A happens, then B happens, then C happens, just like that. What we'd like to do with a loop is to be able to come back to previously executed code, okay? And so it loops around. And that's what we want, and that's what we'll get. So I showed you the repeat block before. That was, it looked like this, right? It took as many blocks as you want on the inside of it, kind of like an if block. It was repeat, and then you gave it a certain number, and whatever you put in here got repeated n times, okay? That's how the repeat block works. And you'll hear me say this term a bunch of times, but just a weird metaphor. The part inside of an if state, or an if block, or a repeat block, the part of that code, these pieces inside that get repeated, for example, that's called the body, we say, of the repeat block. Like it gives it weight. We call that the body for some reason. That's the metaphor. So that's the body of the repeat block. And if you put the number n there, like maybe n is 10, it gets repeated 10 times, right? The body gets repeated n times, whatever you want n to be. So that is what we know already. I showed you that block, but there's more to it. All right, so let's go into loops in detail. So a loop, it's a block that keeps getting run. And that's the key, right? You can specify how many times if you use one of those repeat blocks. Alternatively, there is a forever block. You can make it run forever, okay? So your program never ends with a forever block. Looks just like a repeat block. You can put stuff inside. How do I want to draw it? Has a little mouth like that. So that's the forever block. Never stops. And, of course, its body just keeps on being run, okay? Keeps running forever and ever and ever until the end of time, until you press the stop button on Scratch. All that code keeps running forever. Interesting. All right. So yeah, no matter what kind of looping block you have, the inside of it, the pieces of code that make up the inside, which we call the body, all that stuff gets run usually repeatedly, multiple times. That's the point of a loop, right? And another term for kind of the body, but the process of running the body, we call it an iteration. So if I run all the code inside of that forever block once, that's called one iteration of the loop. It goes around once, and iteration is just a fancy Latin term that means to go, right, from that root. So an iteration is one execution of the loop body, we say. And yeah, there's more than just forever and repeat n times. Repeat 10 times forever. There are also repeat until blocks. Interesting. So they take a condition that can be true or false, and they repeat until a condition becomes true. Cool. So that's what repeat until does. Looks like this. Takes stuff inside, takes a body, as usual, but it repeats until some condition becomes true. And so it's got room for that little condition right there. I'll say cond for condition. I'll write it bigger over here. So there's where your condition goes. And this keeps on getting run. The body of this repeat until block will keep getting run until repeat until cond becomes true. is, let's just say T for true, okay? So are there any questions about these ideas of what I want to do? I have all these blocks, and I put blocks inside of them. I put code inside that gets rerun, okay? Keeps getting looped back to, okay? Any questions about that before I give our first example? Okie dokie. So let's have a example of a bouncing scratch cat forever, okay? So we're going to use a forever loop. Why not? So let's have the program start when the green flag is clicked. And what we're going to do is we're going to have the scratch cat bounce around. So let's start him off in a weird looking direction so he can bounce around. So here's what I want to do. Forever, once the program begins, please, Mr. Scratch Cat, move, 10 steps is fine, move in your current direction 10 steps, okay? That's almost the program. So I click the button, ooh, there he goes, off into the ether. Where is he? Come back, Mr. Scratch Cat, 0, 0. There, now he's fine again. But that's essentially the game we want to play. So right now his direction never changes. So he moves 10 steps, always in the same direction. We repeat that until the end of time, so he goes off the screen right now. There's another nice block, though, that has him bounce off the wall, so let's go there. Where's that one? Go to point towards if on edge bounce. It's like an if block all in one. Interesting. So move 10 steps. Hey, Mr. Scratch Cat, if you hit a wall, also bounce off of it. So that's those two lines. So repeatedly, move a little bit in your current direction. Oop. If you ended up hitting a wall, though, bounce off of it. So he's going to move around like this, which is going to be cool. Okay? There he goes. And so forever, he's going to do this. These two operations inside of the forever loop. The body of the forever loop keeps on running. Going to move 10 steps, and if he hits the edge of the screen, he bounces off. And so we only needed a forever block and 2 blocks inside of it to make this lovely looking program. Any questions about what's happening? We're just repeating code. Kind of cool, huh? All right. So I'll save this so you can have it later. And let's continue if we're doing all right. Let's see, what is the next thing I want to do? The next thing is more programming, less scratch catty. So let's talk about how to do math in a programming language, because that's what they were invented for, right? So let's talk about how to sum all the numbers from 1 to 10. Okay, that's a problem that I would like to solve. And of course, you can change these numbers to anything. What's the sum of all the numbers from 1 to 100, maybe? That's also a possibility. But I'm going to show you a cool diagram of what I want to do on the next slide, don't worry. But I want to say some words first about this idea, okay? I want to sum all the numbers from 1 to 10 and maybe have the scratch cat say that number, whatever the answer is. We're going to compute the answer. So the trick is, when you want to sum the numbers from 1 to 10, the common way of doing it is to make one variable to hold the eventual sum, okay? And what you're going to do is you're going to start it at 0. You're going to start that sum off at 0, and then you're going to repeatedly add 1 into it, add 2 into it, add 3 into it, add 4 into it. Does that make sense? Because eventually you'll have added all the numbers from 1 to 10 into sum, and it just keeps increasing. And eventually it'll hold that right answer after you've added in 10. Yes? So if we start sum off at 0 and we add 1 in, then we add 2 in, then we add 3 in, then we add 10 in, we will eventually have the answer. But look at these bullets. Don't they look super similar and repetitive? These bullets are repetitive. Repetitive. Okay. So, whenever you see repetition, that should scream loop to you. Okay, we should use a loop here to not have to write a bunch of blocks that individually add 1, then 2, then 3, then all the way to 10. Let's make one piece of code that we can repeat that adds each number, okay? And so the trick there is we can use a second variable to keep track of what number we're currently trying to add into sum, okay? I will call it the toAdd variable, okay? I'll start it off at 1, and then I can add the 1 in to sum, make it 1. Sum is what it was plus 1 now. And then I'll increment the toAdd variable, make it 2. And then I could use that same code that adds in to add to sum to add in the 2. And now sum is 3 because it's 2 plus 1, what it used to be. Does that make sense? That's the process I want to keep going over and going through. Okay, then I'll make 2 add 3. And I'll add that into sum. And that'll make sum 6. Okay? And so on and on and on until the end of time, or until we get to 10, I'll do that same process of increment to add it into sum in some order. Okay? So after I've done that, then sum will hold the right answer and I can print it out. Does that idea make sense at a high level? That will correctly sum those values. Okay? So let's first maybe write the code and then I'll draw how it's working. Okay? This is an old screenshot. I'll write a new one. Okay? So let's make some programs. So I'm going to need 2 variables. I've determined to call them sum and to add. I'll rename this existing one from my variable to add. Okay? And here's what I want to do. So when the program begins, I want to start off, right? What are the starting values of these variables? It should have been sum gets to be 0 at the beginning and to add gets to be 1 at the beginning. So let me set those. So set sum to 0, set to add to 1, because that's the first number I want to put into sum, right? And then I want to repeatedly do some stuff. Repeat until might make more sense later, but let's repeat 10 times, right? The same stuff. Because we'll have to add will have a chance being 1 to 10, and we want to keep doing this, okay? All right, repeat 10 times. What do we want to do? We want to add our current value of to add into sum. So let's do that. That means we want to set sum to be whatever it used to be plus its old value of sum plus whatever is in to add, because it'll be 1. So this will add the 1 into sum the first time. Does that idea make sense? It's weird to see sum twice on the same block, but here in the plus, it's the old value of sum. So make a new value of sum using the old value. That's what's going on there. Okay? And then I want to get ready to add 2 into sum. I need to increment the to add variable. So I'll do it once more. I'll do one more block in here. Change to add by 1. That increases it. So now to add will be 2. Does that make sense? And if I show both of these and make this happen slowly in the loop, we can watch it work. So maybe I'll add a wait block just for fun. Wait a second between doing things. Okay. And then at the very end, after this is repeated 10 times, to add will get a chance being 1 to 2 to all the way to 10, right? 10 times. And then at the very end, sum will hold the right answer, and I can say that answer after the repetition has completed, right? I don't want to say it inside of the loop. Say sum for 2 seconds. Okay? So let's watch it happen slowly. Here are the values of the variables up here. Sorry, they're so small, but hopefully you can watch them change. So, beginning. Sum is increasing, to add is increasing by 1, sum is increasing by whatever to add was. We're on 8, adding 8 in, adding 9 in, adding 10 in, and the answer is 55. Yeah, and then a floating scratch cat tells us that. And that's the right answer, okay? Any questions about this code before I draw a diagram of why, how it's working next to the code? All right. Boop. So let's talk some more about why this works. So initially, we had sum. That's what these 2 blocks do right here. We set sum to 0 and to add to 1. Okay? And then 10 times, in addition to waiting eventually, we set sum to be whatever it used to be plus to add. So sum equals itself 0 plus to add 1. 0 plus 1, we put into sum. So now sum is 1. And then we change to add by 1, increment it to 2. Yeah? And then we repeat, because we're doing this 10 times, the same process. So now we set sum to be whatever it is plus to add. To add is now 2. Interesting. And sum is now 1. So 1 plus 2 is 3. Put that into sum. That's the new value. Increment to add. See how this is working now? Maybe that makes more sense. Now we add 2add into sum one more time because we're repeating the same thing 10 times. Now sum becomes 6. 2add becomes 4. And eventually, we're going to get to the very end. It's going to be like 45, and we're on 10, so we're going to add 10 into sum, so we make it 55. And then we're going to change 2add by 1 one more time. 2add becomes 11, and that's when we can stop. Okay? So that's another condition. If we wanted to use a repeat until, we can notice that we can just stop whenever 2add gets bigger than 10. So that's a Boolean condition that will make that work. We can talk about that later, though. Any questions about this code now? Does that make any more sense, how it's working? Summing all the numbers from 1 to 10. All right. Let's see here. Dun, dun, dun. Let's change it to be a repeat until, just to show you this, how it's working. Because alternatively to repeating exactly 10 times, we can just repeat until, dun, dun, dun. We can repeat until the 2add variable gets bigger than the number we want to put into sum. If it becomes greater than 10, then we want to stop. So I can have the greater than here. Repeat until 2add is greater than 10. Once it becomes 11, I don't want to do anything anymore. I don't want to continue repeating this code. Okay? That's what I would like to do. So this will do the same thing, because 2add will eventually be 1, 2, all the way to 10 to 11. Oh, sorry, once it's greater than 10, once it's equal to 11, this will stop, because this is now true, right? It repeats until something is true. And so again, very slowly it's working, because it's waiting. But it will again compute 55. Any comments, questions about that? Why this is working, why this is a good condition to stop the loop? All right, because now I have something for you to try. So here's my code, if you want to look at it. Get into your peer instruction groups, please. Introduce yourselves if you're sitting next to somebody new today. But instead of adding the numbers from 1 to 10, I would like you to try to add the numbers 1, 3, 5, 7, 9, all the way to 25. So add only the odd numbers from 1 to 25. See if you can compute that. Okay? I'll give you a few minutes to try that. Let's take like 3 minutes or so, and then I'll do it with you. What do you need to change? How do you make it add 3 next instead of 2 next, right? And 5 after 3 instead of 4. So think about what needs to change. See if I can make this bigger for y'all. up to 25. Alright, that is my timer. Let me just put some notes on this slide for future me. Insert, and then we'll talk about it. Actually, insert text box. Okay, well, that's good enough. So, the very first number you want to add is still 1. So it's okay to start at 1 again still, right? And then some should stay 0. But when do you want to stop? What do you change the repeat until to be? What should that become? Because we want to keep going. We want to keep going once 2 add is even 25, right? So it better be allowed to get bigger than 10, yes? What should be the number that I put there instead? Yeah, it's just 25. Because 25 is the last one I care about. If I change this to just 25, then once it gets any bigger, I will be unhappy, okay? And then I'll stop the loop. Then, that's almost right. This will add all the numbers from 1, 2, 3, all the way to 25. How do I make it add only the odd ones? Which part do I change? What were we thinking there? Which block used to make 2 add, or still does, which block set 2 add from 1 to 2, right? Because we want to change it to go instead from 1 to 3, straight to 3. Which block was doing that? Yeah, it was this one. So instead of changing it by 1, which increments it by 1 each time, what should I change it by? Yeah, just 2. Then it'll be 1, 3, 5, all of those. So let me save this so that you have at least this version. And then let's do exactly that. So stop once it gets bigger than 25 and add it by 2s. And there it is. You can see 2 add incrementing by 2 each time, some getting bigger. That should do it. 2 add is going to become 27, and that's going to stop the loop, right? And it looks like the sum is 169. Now we know. All right. So that was the key thing to change there, that condition right there. Any questions about this? All right, because I have more fun examples. Let's do some more operations. Let's remember how to use if blocks again. So let's make a fun program that I have titled, Do You Believe in Ghosts? We will hide and show ghosts based on a Boolean condition, okay? So let's do this. This is the program that I want to write. Let's ask the user if they believe in ghosts. And if they do, we will keep track of that answer in a variable, okay? Which I will call should show ghosts. Which will only ever be 1 or 0. Because you can't store true or false, apparently, in Scratch. Should show ghosts. And if they say they do believe in ghosts, we'll set the should show ghosts variable to 1, right? Otherwise, we'll set it to 0, right? It's either 0 or 1, updated appropriately. And we're going to have some ghosts hidden, waiting in the background, okay? And they will be summoned the second the value of should show ghost changes to 1. That's going to be their cue, okay? That's how this game will work. And that is all that we have to do. We're just going to have a bunch of ghosts initially hidden, and they're going to be watching this special variable that we're making, and if it ever becomes 1, they're going to show themselves. So all the ghosts, their sprites, will be having their own little programs watching the value of the should show ghosts variable, seeing if it changes, or if it ever becomes 1, I need to show myself, or if it becomes 0, I need to hide myself. Yes? That is the game plan. So, let's see here. Is that what I want to start with? Yeah, so Any questions about the idea before I implement it? Should be fun. All right, so let's just make something brand new. And we got to set the scene, of course. There should be like a woods. Yes, we got a woods. And we need some ghosts. Let's make that happen. I think there was, we got a bat. That's close enough. Let's have 3 ghosts. I think there is like a real ghost somewhere, so let's remember to keep that one. Ghost. And I think there's like a skeleton too, so let's add that guy too. So here are my ghosts. A bat, a skeleton, and a real ghost. And they're initially going to be hidden. Okay, so when the program begins, each of these sprites are going to hide themselves. Okay, so that is something that I need to remember to do. So at the beginning of the program, so I guess let's just have it start when the green flag gets clicked as usual. Let's make sure to hide all these sprites. Remember that every sprite gets its own program. So the bat, when the green flag gets clicked, can do something different from the ghost when the green flag gets clicked. We want them to do the same thing, though. The scratch cat can be different. All right, so when the green flag gets clicked, I want to make all of these ghosts hide themselves. So let's do that, and then we'll work with the variables and things. So it looks right. Hide, and I want everybody to be doing this when the green flag gets clicked. So I can I should be able to transfer this by dragging it. The same code, so the bat has this code, the ghost has this code, and the skeleton has the same code. So when I click the green flag, they all hide each other, hide themselves. Does that make sense? So that's that. Let me show them just to make it so that I can restart all this. Now, as far as the scratch cat goes, the scratch cat is going to be the one driving this. He's going to ask the question, hey, do you believe in ghosts? So let's do that. Where is the, oh, it's in sensing, isn't it? Ask, do you believe in ghosts? And wait. And then we're going to use this special answer variable to determine whether or not we should show the ghosts. Yes? So, this is the trick. Let's use that should show ghosts variable, because that's the best name I could come up with. And we're going to have that control whether or not they appear. All the ghosts are going to be watching the should show ghosts variable. So let's make a variable called that. And I'm using underscores because in most programming languages, Scratch is fine. Scratch is happy with variable names with spaces in them, but pretty much every other programming language is not happy with variables with spaces in them. So that's why I'm getting used to this now. So should show ghosts. Let's set that to be whatever the user types. So if the user types yes, we're going to set should show ghosts to 1. And if the user types no, we're going to set should show ghosts to 0. Okay? So depending on what they type, it's either setting it to 0 or setting it to 1. Okay? Based on this answer. It's going to hold yes or no. How do we do one thing or another in programs? We use if else. So if something, set it to 0, otherwise set it to 1. Does that make sense? So what condition should I put here based on the answer, right? So if something is true, then I want to set it to 0. So that what would answer have been to make it 0? Yes or no? There's an equals to somewhere. There it is. So remember, 0 hides the ghosts. So if answer is equal to what, should I hide the ghosts? Yeah, they type no. Good question.
Can you also use the contains one?
Yeah, that would work. Then as long as they type something that contains the word no, it would be happy. But if they type yes space no, it would be still true. So you might want to be concerned about that. I don't know. But you can combine using and and or. Like if it contains no, but it doesn't, and it also does not contain yes, something like that. That could work. But yeah, it's totally fine. but this is probably the quickest way to get there. If answer is equal to no, then we're going to set the should show ghost variable to 0. Otherwise, we'll set it to 1. And then that's all the scratch cat needs to worry about. It's the ghosts now that are going to be watching this variable, right? Forever. Forever until the end of time. So, forever, these ghosts are watching this variable, okay? Forever, hey, did it change? Maybe I should show myself. Hey, did it become 1? I should show myself. Hey, did it become 0? I shouldn't show myself, yeah? So, let's do it this way. If they start hidden, we only ever need to show them, right? So maybe I can just have a single if. So if the should show ghosts variable became 1, then I need to show myself, yeah? That's what we want to do. So if it's equal to 1, that's their cue, then I'll have the ghost show itself. So the opposite of hide there is show. Does that make sense? So we don't know how long the user is going to take to type, so they keep watching this variable forever. But eventually, should show ghost may change to 1. If so, that ghost is going to show itself. And this is a program specific to this ghost, to the bat right now. This is the Scratch Cats program. Remember that they're separate. They all start at the same time. Any questions about this idea? There's an easier way to do this when we talk about events in more detail. But this is a good start. All right, so every single ghost needs the same program. So let's get rid of these initial pieces and give them the full program. So I can just drag it, which is nice. So now the ghost has it, and then I'll drag it to the skeleton to give the skeleton also that program. All right, so if we get it right, we'll see. That means Scratch Cat is going to start, ask us, do we believe in ghosts? If the answer is no, then we're going to set should show ghosts to 0. Otherwise, we're going to set should show ghosts to 1, and that'll be that. Then these sprites are going to be watching for that value to change from 0 to 1, for example. And then they'll show themselves. So, what is the current value of should show ghosts? It is initially 0. This might, there's a slight issue right now, and I think we'll notice it. So let's make it happen. So, initially, green flag gets clicked. Do you believe in ghosts? All these guys are hiding themselves, right? The bat hit itself, and it's waiting to see if the value changes. Same with the ghost, same with the skeleton. And now if I type no, right, and hit enter, it stays at 0, right? Should show ghosts is currently set to 0, and it stays 0. And that's the end as far as the Scratch Cat is concerned. But the program's still running because this is a forever loop for all these guys. So that's fine. If I click the green flag again, do you believe in ghosts? Yes. That'll set it to 1. And then they all appear. Isn't that cool? So now the variable is set to 1, and they show themselves. Okay? What might go wrong if I restart the program right now? Any thoughts? Take your bets in your mind right now. Go. What? They were supposed to hide themselves. I had code for them to hide themselves, but look at what happened. What's the current value of the should show ghost variable? It's the value from the previous run of the program. It's currently 1. What should I have done to should show ghosts at the very beginning of the program always, if I wanted this to work as it used to? I should have initialized this variable to something. I should have initialized it to 0, shouldn't I? See how that'll work? That'll fix it. Keep it 0, maybe reset it. Depends on what you're thinking. That's one option. Alternatively, and I think the way that I would prefer, if you will stick with me, is let's have maybe in if else, and maybe they can start being shown from the previous version. Let's change this to if else, because we'll have it show when they're 1 and hide when they're 0, maybe. That could work. Dun dun dun. If should show ghosts, oh no, is equal to 1, then we'll show, otherwise we'll hide. That's fine, that would work. You used to not believe, but now you do. Something like that. Or you used to believe, but now you don't. So now I don't even need this initial hide, actually, but we'll keep it in there for fun. That's another option. This will always make it so that it follows the value of the variable, even if it's 1, even if it's 0, depending on how it starts. So that's a new way to do it, a new way to think about it. Let's see what happens if we do it that way. And it's always fun to play around. So now they all have this program. And we're still not initializing that variable, so we're just keeping whatever it used to be. Should show ghosts right now is still 1 when I run the program. So the ghost won't disappear if I type yes. It'll keep on staying 1. Stop, restart the program. But now if I say no at least, they will hide themselves, because should show ghost will be set to 0 and they will hide. Okay? So it's following that pattern. So now we can start believing, yes. Stop the program, stop believing, no. Are there any questions about how this is working? That's a fun little, more involved program, because we got a bunch of different programs running at once, right? A bunch of copies of this one and then the scratch cat doing stuff to the variable. But everybody's watching that variable. That is the key, okay? And so I think I've said what I wanted to say here. So when I enter my answer, the answer variable got changed, and we used that to set the should show ghosts variable using an if block. And then we had it so that each ghost kept checking the value of that should show ghosts variable, and they ended up hiding / showing themselves based on it. Okay? We used that variable to send like a message to the ghosts. Does that idea make sense? Any last questions about it before I have you try something? So, if you were not following along and doing this with me, let me save this and give it to you in Discord, because I want you to take this and try playing around with it. Sorry that Discord is the only way for me to give it to you at the moment. It looks like it's Scratch Project 2 that I will be giving you. Well, let's wait for Discord to load itself. As it does. Here's what I'd like you to do, though, once I give you this. Take a few minutes, try this, see if you can recreate my example, or copy the one that I'm letting you download off of Discord, load it up, and add something. Like maybe when the ghosts all appear, have them say boo. Make the program your own so that you understand what's happening, okay? Try to make something cool, impress your neighbors. And then yell at me if you have any questions. Come on now. There it goes. All right, so you have my code if you want it. And I can also put pieces of it up here if you are interested. So maybe think about, like, what would you put here? How would you change this to say boo when the ghosts appeared, right? What would need to happen? Is it something you need to change in the Scratch Cats program or the individual ghosts program, for example? So take a few minutes and try that out. Have fun. What else could you do? You could introduce sounds, like the cat gets scared when the ghosts appear. You can have them meow, right? Play sound meow. And I think each of these sprites each get their own sound as well. So the skeleton has a rattle sound apparently. That's eerie. The ghost has this sound. Okay. What does the bat have? Interesting. I don't know why the bat makes an owl noise, but apparently he does. What else could you do? Looks could also be fun. You could make them all transparent when they show each other. Like that would be change the ghost effect, aptly named by 25 apparently. So there's a transparent ghost. That could be cool. Yeah, but just try something. That'll help you understand this program. Right, or maybe you could make like a plot twist. The cat was also a ghost, and so he himself disappears if he doesn't believe in himself. That would be fun. All right, but I hope that was enough time to try something out, see if you could make the program even cooler. Are there any questions before we move on? There will be plenty of time to come back to this if you're interested. So the last thing I want to show you before, also remind me to introduce your next programming assignment because you got one due this week. I want to talk about how to make a game, like a platformer game. And if you care, the reason these are called like Super Mario Brothers, the reason it's called a platformer game is because you move left to right and then you can jump on these little platforms. That's essentially the reason. Let's make one of those, okay? Let me show you how to do that. So I did save the program. We're good there. I'll make a brand new one. But here's what we want to do. Here's what I'll teach you how to do to make this kind of platformer-looking game. I want to make it so that the Scratch Cat can move horizontally when I press the arrow keys, for example. Maybe I want the Scratch Cat to be able to jump, because you can usually do that in those games. Maybe when you press the space key, I'll have the Scratch Cat jump. And then we want him to be able to interact with the things around him, like the other sprites that exist in the little world that we're building. So let's see how to do all of that, okay? All right, let's do horizontal movement because that's the easiest. So here's the scratch cat. I want to be able to press the left arrow, make him move left, press the right arrow, make him move right, and then space, he jumps. So let's do left and right first. No. All right, so do we have any cool backdrop that we could put here? Any Super Mario looking backdrop? Mountain, space, city. There we go. So you can be in space right now. All right, so let's see. What do we want to do? So let's have him move left and right. Actually, I remember my idea. Let's make him under the ocean. Underwater 1. Yeah, even better. So here's a scratch cat. He's in the ocean. And let's make him move left and right. To make him move, right, you can just change his x and y coordinates, right? Change x by something, change y by something. If you change x by positive 10, he moves 10 to positive x land towards the right. So all we have to do is hook that up to like an arrow key. So when the right arrow is pressed, change x by 10. So now I can press the right arrow, and the scratch cat's going to move to the right. I can hold it in, he'll glide to the right. That's not too hard. Then same with the left arrow. When the left arrow is pressed, then don't change x by positive 10. We want him to go in the negative x direction, right? So change x by negative 10. Does that make sense? Because I can just keep clicking this, and now he moves backwards, does the moonwalk. So now I can hold in, press left and right, and now I have a horizontally moving scratch cat. That wasn't a lot of work to get that. That's cool. All right, let's now do jumping because that's the harder one. So that's going to involve changing y by 10 or some amount, right? Because he's got to move up, and then if it's a jump, he also needs to come down. So let's figure that out. Okay. When he's down here, we want him to jump like up to here immediately. So maybe we can increase the y value by like not 10, but like maybe 50 or 100 or something. And that'll teleport the scratch cat up to the top, like that was his fast jump. And then we want to bring him down slowly to the ground. Okay? We can do that with a loop. So that's what we want. Okay, so when the space key is pressed, let's have him jump when the space key is pressed. So let's change y by like, I don't know. Let's see if 50 is enough. Is that a good jump? Space. No, we need like 100. Or 150. Who knows? Yeah, that's a good jump. Okay, so in that case, he's going to move up by 150, which means he needs to come then down by 150 as well. But let's make that part animated. So that will be change y by some small amount, like negative 10, but do it 15 times so it's animated. Yeah, so that can be a repeat block. Not repeat until repeat, like 15 times, because that'll bring him down back to where he started. I repeat this minus 10 15 times, that'll go down 150. Yeah. So let's see what happens there. Is that a good enough jump? Yeah, looks like a jump to me. So he teleports to the top and then he comes back down. Does everybody understand why this makes him jump in this way? So initially teleport him up 150 units and then slowly 15 times repeat this animation of just come down by 10 a bunch of times fast. Any questions about that? So now I can make him move left and right and jump. Cool. And that is the start of our little platformer program. So let's make little goals for the scratch cat to jump to. So he's a cat, he likes fish. So let's add a fish sprite and have him get a point whenever he touches a fish. Like he jumps up and he touches the fish. That will be him catching it. So let's make that happen. Let's introduce a fish sprite. Fish. There's a fish. We'll put him up there because we want him to get to it. There. Then whenever the scratch cat touches the fish, we want to give the scratch cat points. So we'll make a points variable. Start at 0, of course, when the game starts. So maybe now I need to initialize the points. Maybe when the green flag is clicked. Got a lot of different separate programs running depending on key presses, green flags, but I think that's as good as it's going to get. And then now for the fish, as far as the fish is concerned, we want to give the scratch cat points whenever he touches that fish. Okay? That is the goal. And so maybe after we set the points to 0, we can keep checking repeatedly, hey, is the scratch cat currently touching a fish? And you can do that in sensing. There is touching, question mark, a sprite. So is the scratch cat touching a fish? Right now it's false. If I put him next to the fish, it's true. That's my condition that will change based on whether or not he's touching that fish. So now I can use if. So if he's touching the fish, give him points. If touching fish, then increment points by 1 or something. Okay? Does that make sense? So we need to keep track of that points variable. And he'll get a point every time he touches a fish. Okay, then we'll worry about making the game more exciting in just a second once we got all this working. So, click the green flag to start. Program begins. Oh, sorry, we need to repeatedly keep checking this, not just once. So forever, see if the scratch cat is touching a fish. If so, give him points. Don't just immediately check. Try until the end of time. So now that keeps running. So I jump up, no fish. Let's show all the variables. So points is 0. I jump up, not touching the fish. Still points is 0. If I jump up underneath the fish, oh man, he got 2 points at a time because it looks like for 2 animation frames he was touching that fish. That's why it works like that. To get around that issue, you can make it so that he just ever so slightly touches the fish once. That's one way to fix it. Otherwise, you could add a weight. Don't give him extra points if he just got one. Something like that. But now, every time he touches the fish, he gets 1 point exactly. So now he's going to 20, 21, 22. And now I can restart it. Points is at 0, and it forever keeps checking if the scratch cat is touching a fish. If so, give him a point. 1, 2, 3. Now he's not getting anything. So let's pause here for questions. Are there any questions about how this code is working? Why I needed a loop? Why this is the right condition to give the scratch cat points? Things like that. Do all the individual blocks make sense, and do their combination also make sense? All right, there he is, touching the fish. So the last thing that I want to do is make the game a bit more exciting. Let's do this. Let's make the fish disappear once we touch him. And then he'll teleport to a different x-coordinate. He'll move horizontally. So he starts here, and then he randomly moves over here after we touch him once. And then he randomly moves over here after we touch him twice. Something like that. Does that make sense? I think that would be a fun game. So now, here's what we can do. When the green flag is clicked, we can, on the fish's end, forever keep checking if he's touching the scratch cat, right? Because it's always from his point of view, if it's his program. If I'm touching the scratch cat, then I better... Oh man, we're calling him Sprite 1 right now? No, your name is Scratch Cat. There. If we're touching the scratch cat, then we should teleport. And this will also handle the multiple points issue as well. If touching the scratch cat, then immediately teleport. So this would be set x, right? because we don't want the fish's Y position to change. We want him to stay up here. We just want him to randomly move along this line. And that will be set the X, not the Y. Does that make sense? That's what we want to do. So set X not to 10 always, but set it to like a random number between, or what are our options? Like negative 150 and positive 150. Where's my random numbers? Pick random between negative 150 and positive 150 and set X to be that random number. Well, that should do it. Let's see what happens if the scratch cat touches the fish now. I brought the fish up too high, it looks like. Yay! So the scratch cat got a point, and then the fish randomly teleported. Whee! There he goes. Whee! There he goes. Now it looks like I have a little bug right now because the scratch cat isn't noticing that he's touching the fish. Oh no. And I think the issue is we need to be touching just in one place. So maybe let's not worry about the scratch cat touching the fish and changing the points. Let's have it be from the fish's point of view. If we're touching the scratch cat, then give him a point and then teleport. That should fix it. There it goes. 1 point, 2 points, 3 points. Isn't that cool? Any questions about this now? How to make a teleporting fish? That's this random X coordinate that we're setting the fish's location to. Think we could do this ourselves? Are we doing it ourselves and having fun? So I think the very last thing that I want to try with this program is don't make the fish immediately teleport. Like, give him a little bit. Let's do it this way. So just have him like plop and go away for a second. And then after some time, teleport to a new spot. That's how most games work, right? The coin goes invisible for a second and then appears somewhere else. So if we ever touch the scratch cat, then let's hide ourselves, teleport, wait a little bit, and then show ourselves. A second later, we'll plop in a new spot. Does that make sense? I think that would make it the most enjoyable. So now if I touch the scratch cat, gets a point, and then the fish hides for a second. See how he's kind of going out of view? That's more like a game. Yay. 6 points, 7 points. And of course, I'll give you all this code, but does this ordering make sense? Like, if the fish is touching the scratch cat, then we got to give him points. Then we should hide ourselves. Let's then teleport while we're hidden so that we'll end up in a new place when we show ourselves. Then let's wait a second so that we stay hidden for a little bit. Then finally we can show ourselves in our new position. That's the order that it has to be in. Technically you can change points whenever you want, but these 4 last blocks, they have to be in that order. Does that make sense? To make this happen. Eee. Not doing very good at being random, is it? But that is probably the coolest program of the day. Any questions about how to make this little game? Let me save the file so that you get the code. All right. If we're doing okay, I think it's time to let you get started on your own version of this kind of game, because your next programming assignment is make a platformer game. Just like this. Dun, dun, dun. So, here is your next programming assignment for you Scratch people. The non-Scratch people have another assignment down here. So here's what I want you to do. Make a Scratch program with the following features. So you have some character sprite. You can delete the Scratch cat, add a new one. Totally fine. Make it fun. I want that character sprite to walk, right, with left and right keys and jump with the space key, at least to that. You can do cooler stuff with other keys if you want, but at least that. And then I want something cool to happen. Not exactly what I just did, right? But something else. Make something cool happen when you touch another sprite when you jump up and hit another sprite, maybe you can make like the Super Mario block or something. So that's what I want to have happen. So you're going to need an if and a loop, just like we were doing here. That's me forcing you to try out those things and use those things. So that's that piece. And then I want you to have at least 2 loop blocks in your program somewhere. So at least 2. So maybe a forever and a repeat, for example, but at least 2. All right. And you can use my demo as a starting point, but you should not copy it exactly. So your something cool better be unique and not exactly my fish game where the sprite disappears. Okay? So that is your assignment. Are there any questions about it itself? Not too bad. Hopefully you have some ideas in your head already. What I'd like you to do for submission is, now I'm finally requiring a video submission. Okay, so I want you to record your screen. You can do it with your phone if you need to, but there are programs that I can teach you how to use. Right now I'm using OBS, for example. Zoom can record, whatever you need to do, but I want you to record a video showing your game in action and also your code. Talk about how, like, okay, this piece is running when I press this. Things like that, so that you understand it. Prove to me that you understand the code that you wrote. Okay? It doesn't have to be a long video. It could be like 30 seconds to a minute, whatever you need to demonstrate your code and show to me that you understand your program. Okay? So that is your game. Any questions? I think that's all I have for you. What's that? Yeah, just make a quick video. It's like, okay, this is what's happening. This is how my game works. Here's the code. What? That's what you'll submit after you complete the assignment. Okay? Yeah, so you're going to submit a video to Canvas.
So do the assignment first and then record a video.
Yes. Exactly. Any other questions? And then my programming people, you have some more stuff to do. Also record a video for you as well. I think you'll be drawing cool things in Racket. So if there are no other questions, I think that's all I have for you. So you can get started on your assignment now. Is there a question in the back? Yeah, of course. I'll do that. Let me stop this recording first, though.